Hi, everybody. We're going to get started again. Please have a seat. Please come on in if you're still outside. Sit down. And we actually have a small event before we start the session for an award.
Hi, everyone. I'm Christy Morris. I work for the National Park Service Air Resources Division, and I know we gave out some great awards this morning, but we do have the opportunity to hand out an award in person. That is to Jonathan Jernigan, who is our site operator from Kentucky 10, otherwise known as Mammoth Cave, which is the longest cave system in the world. Yes. So Jonathan has been collecting samples every Tuesday for 20 years for the NTN network and MDN as well. So Jonathan, thank you for your commitment.
Okay, we are ready for session one, and my co-chair, Sarah Jovan, is going to introduce this session for us. So go ahead, Sarah. She's online.
Thank you. Linda, can you see my slide with the overview of our session?
No.
I'm sharing it, so I'm not sure what's happening.
Will you try resharing it again?
Yes. Give me 1 second here.
Oh, we see your face.
You do?
Yes.
All right, I'm resharing. How about now?
Looks good. We not in presentation mode, but we see it. There it goes.
Okay, great. Great. Well, thanks everyone for joining us. What's cool that Dr. Kraft gave, in a way, a really good introduction to a lot of the ideas that we're going to cover in this session. So the title is Diversity, Equitability, and Inclusion in Air Quality Monitoring, Serving Urban and Rural Communities, Promoting Public Awareness and Access to Information and Decision Making. And so that's a lot to unpack, but all pretty important ideas. And I just wanted to say a couple things before we get started. You know, this is a very timely subject as it becomes increasingly clear how, you know, the burden and awareness and capacity and ability to engage with air quality issues varies really widely across different groups of people and sectors of society. And so I'm excited to have we're excited to have these 4 talks lined up that approach these ideas in different ways. I think we're ready to start.
Great. Thank you, Sarah. So our first speaker is Doug Kaler from US EPA, and his talk is on the screen right there. Very good. Go for it.
Hey, good morning, everybody. I'm going to try to fit this into 20 minutes, but it's a lot. So the title of my talk today is Past, Present, and Future of Adversity and Public Welfare in the Secondary National Ambient Air Quality Standards, which is a mouthful, so we're going to say NAAQS. I've structured it into roughly 2 segments. And so firstly, we're going to look at the definitions of public welfare and adversity in the context of the NAAQS, how these concepts have been understood historically and presently. And then we're going to take a look to the future and examine how science might better inform the NAAQS and how we can start thinking about things a little differently. I want to acknowledge my co-authors. Many of them, you know, they're sitting out here. Jeff Herrick, Rebecca Dalton, Chris Novak, Tara Griever, Emma Leith, and Caroline Ridley. This has really been a collaborative effort, and we've all sort of wrestled with these ideas together. I'm just the one up here standing speaking. I also want to acknowledge the colleagues in my branch, the Environmental Assessment Branch at RTP. They've also contributed valuable ideas and insights. So first, I want to start off with a general overview for the process of the NAAQS, because it can be a little opaque to people who are not part of the EPA and working with it every day. And so I want to acknowledge that there are two standards for critical air pollutants. There's a primary standard, which protects the human health, and then a secondary, which is what I'm focused on today. This process starts with the planning phase, which outlines the scope, the process, the timeline, and the approach for reviewing a particular set of standards. This is reviewed by an independent panel of experts known as CASAC and by the public. This leads into the assessment phase, which assesses the best available scientific information on the effects of an air pollutant on public health and the environment. The assessment phase also includes assessment of the adequacy of the current standards and alternatives. Again, this is reviewed by the public and by CASAC. And then this information goes to the EPA administrator, who uses the science as a basis to judge the current standard, issue a rulemaking, and set standards. This is again reviewed by the public, and after that, it's finalized and goes to the states for implementation. So that's a brief overview, and we're going to focus today on the assessment phase and the rulemaking phase. This is the interface of science and policy. This is how science and policy work together. My group works on the assessment phase, so we can think about ways to improve the way that science informs policy. And in this talk, I'm going to be focusing on previous rulemakings and think about what's been included in assessments previously so that we can get an idea of how all this works together. So the primary piece of legislation which determines how the NAAQS process works is the Clean Air Act. And this particular chunk of text, which is a wall of text, I realize, is where they discuss the secondary standard. And so what I want you to focus on is here, that the secondary standard shall be set at a level to protect the public welfare from any known or anticipated adverse effects. So there are two pieces of this that I want you to think about that we have to know and understand in order to set a protective standard. One is public welfare. The second is adversity. So we need to understand these things and what they mean in order to set protective standards. So firstly, for public welfare, we can again look at the Clean Air Act and the language that is used. I'm going to draw your attention to three things. One, there's a list of endpoints that are defined and considered as public welfare. And these are things like effects on soil, water, crops, vegetation, animals, visibility, weather, wildlife, etc. The second thing is that this list also includes less well-defined terms, like that reflect personal values, like personal comfort and well-being. And the third thing that I want to point out is the Act acknowledges that there may be other things that are public welfare, but that aren't named explicitly. So these two quotes that I've shown from the Clean Air Act lay the groundwork for thinking about adversity to public welfare. We know sort of what public welfare means, and then we can think about what might be adverse. Here we looked at the rulemakings for information. And we thought about this in the ways of what is the science that underpins the consideration of adversity to public welfare. So we looked at the rulemakings to first review the definitions of adversity to public welfare. What does it mean to be adverse to public welfare? Then we looked at the endpoints that have historically been considered adverse. We reviewed the scientific aspects or characteristics of those adversity judgments, and also led us to two sort of side questions, which is, are all ecological effects considered adverse? And is a judgment of adversity enough to promulgate a standard? So, like I said, we looked at all the rulemakings, which is a giant undertaking in and of itself. There are a number of criteria air pollutants that we looked at, oxides of nitrogen, oxides of sulfur, ozone, particulate matter, and lead from 1970 to the most recent runs in 2020. And so we spent a lot of time looking at legal language and rulemakings, and I'm gonna summarize some of our findings using leading questions. So the first is, how do definitions of public welfare inform what science is needed? So first I want to say that there's no academic definition of public welfare. I could ask each of you what adversity to public welfare means, and I'm going to get 100 different ideas. And so the rulemakings reflect this. The 2012, Knox-Sox rulemaking says, quote, "There is no specific definition of adversity to public welfare." And the 2020 NAAQS rulemaking tells, ozone NAAQS rulemaking goes a little more into detail. It says that the secondary standard is not meant to protect against all known or anticipated ozone welfare effects, but rather those that have been judged to be adverse to the public welfare. And there are no established measurements for when such welfare effects should be judged adverse. So, and it further states that this is a policy decision to be made by the administrator. So there's no specific definition, but this actually leaves us quite a bit of room as scientists to help inform policy. Next, we asked, what are examples of scientific information used in evaluation of public welfare effects? And the 2012 Knox-Sox rulemaking gives us this. It specifically highlights disruptions in ecosystem function and structure. And so it's quite a broad set of endpoint categories that we can think of as disruptions to ecosystem structure and function. They also say that this adversity to public welfare might consider the likelihood, type, magnitude, and spatial scale of the effect, as well as the potential for recovery and uncertainties. And so we can look at the effects considered adverse to the public welfare over the history of NAAQS rulemakings for more insight. So what ecological effects have been judged adverse to public welfare effects? So first I want to say that there are lots of ecological effects of air pollutants, right? Not all of them have been judged adverse. So some specific examples might be effects on vegetation. So injury to vegetation is judged adverse in the SO2 ruling. Declines in biomass for tree seedlings is considered as a proxy for the full array of vegetation-based effects for ozone. So these are adversity judgments that have been made. There are also ecosystem level effects like terrestrial nutrient enrichment and contributions to estuary nutrient enrichment. So not all ecological effects that have been judged adverse even lead to a change in the NAAQS. And this is usually due to a lack of scientific information supporting the quantification of a standard. So what sorts of scientific information is needed to impact the standard? Well, first, we need to have some idea of ecological adversity to public welfare, which is what this talk is about. And this is usually something like national scale effects. And we can compare this to, say, public health. So health might be an individual-based measurement. So one person is healthy or unhealthy, but public health is a matter of populations. This is a matter of scale, and it's the same for ecological adversity. And then secondly, that there's some sort of valuation measurement that shows that benefits are being lost. The strongest evidence for underpinning the NAAQS is quantification of an exposure response function, which should include some sort of information about the indicator, the averaging time, level, and an acceptable level of uncertainty. So that's sort of the part of my talk that's about the past and thinking about our understanding of adversity to public welfare, how it's defined, and how science is used to assess and inform the setting of the standard. But science is changing and our perspectives are changing, and we need to start thinking about different considerations in the future that we need to be prepared to address. So there are advancements in our capacity to do scientific research, including greater computing power. We no longer have to use punch cards to analyze data. We can incorporate large-scale spatial science and satellite data. We can think about big data and things like that. Also, addressing the climate crisis is going to take a whole new set of challenges to bring with it. We have to consider impacts at multiple spatial and temporal scales. And at the same time, we're trying to incorporate a diversity of voices. This is where considerations of environmental justice and equity come in, as well as thinking about the cultural significance of ecosystems and species. And this is where we need to start thinking about incorporating a diversity of values within science and policy. So there are different values that people give to nature, and some of them are intrinsic and some of them are instrumental. How do we start thinking about incorporating a wide diversity of values? I can say that we as a group of scientists are probably missing endpoints that speak to every pool of values on this chart. And that we historically have probably been more toward the instrumental side of things that we can measure, but that we're making strides in trying to change this. Additionally, remember that the Clean Air Act says that public welfare includes personal comfort and well-being, but this isn't easily covered in ecosystem services frameworks or evaluation methods. We know that people's life and well-being depends on nature. The time in the pandemic has shown us that, like, go out in the green space and it's important for your well-being, but we don't really know the mode of action for how that affects people. And so we're trying to currently do work that incorporates the interface of human health, well-being, and nature. And then thirdly, this is a big country and not everyone can agree on what they value most. And there are voices that have been historically excluded from this conversation. So how do these ecosystem values and how do we view them through the lens of environmental justice? How do we get more people to the table and to think about ways in which different people value ecosystems and protect it all? So all of these topics may be relevant for the NACS, but it's also relevant to the scientific community at large. For one thing, information that we deal with during the NACS review is used by a number of other agencies. And for a second thing, science doesn't happen in a vacuum, so all of your science helps us to do this better. So it's a conversation, a dialectic, and that you might be having these same considerations and maybe further along than we are. And so this conversation needs to happen and we need your expertise. So what might thinking about values and ecosystems and environmental justice and spatial scales and all of that put together, what might that look like? Well, one of the ways that we're thinking about this is thinking about possibly an at-risk assessment. So very recently, the National Academies of Sciences reviewed the assessment process for the NACS and published a report, the Advancing the Framework for the Causality of Health and Welfare Effects to Inform the NACS. And in it, they state that welfare and health effects are both impacted by variability and vulnerability and susceptibility. And they say that EPA devotes considerable discussion to identification of populations or life stages to be most at risk within health effects, but provides only a single paragraph of guidance for addressing this topic as relevant to welfare. So thinking about particular populations that might be vulnerable or susceptible, sensitive, or at risk might be one way that we start thinking about these things. And so an at-risk assessment might include spatial representation across the US at different scales in different places. It might also include looking specifically at National Park Service lands, Class 1 areas, because we as a society have said those things are important. It would include specifically looking at rare, threatened, and endangered species and the effects of pollution on those species. It would include interface with tribal people so that we can think about ecosystem services or species or ecosystems of cultural significance, and also considerations of environmental justice and equity. And so other things we're thinking about a lot and wrestling with in our work, and that NASEM helpfully distilled down into a quote for me to read, is that biodiversity, sustainability, irreversibility, and ecosystem cascades could help aggregate multiple ecological endpoints and also convey a sense of the magnitude and scale of the diversity of ecological effects. So these are things we're thinking about and moving forward as we continue to develop our approach to dealing with adversity in the public welfare. And so in summary, I want to say that there's no specific definition of adversity to public welfare, but that some public welfare categories are clearly defined in the Clean Air Act, and that there's room for others. There are adversity judgments made by the EPA administrator and the NAAQS rulemakings, and these can help inform us in our process as we move forward. There are scientific aspects of adversity judgments that we can then use to improve the quality of our science that informs policy. And there are also future considerations that we need to start thinking about. These are diversity of voices, more integrated with climate response, the power of big data and different spatial scales, potentially new frameworks to characterize at-risk or sensitive populations, and lastly, continued and improved focus on biodiversity, sustainability, irreversibility, and ecological cascades can help improve science and policy. And so our next steps is that we're trying to work on a paper to start thinking about these, to both present this historical data that I've presented to you, as well as their thoughts about the future. We'd also like to put together symposiums at professional conferences like this and ESA to start incorporating more of other people's viewpoints and voices. And we'd also like to put together maybe a special issue of a journal so that we can also get more conversation going. And so that's it for my talk. And if there's time, I'd like to take questions. Great. Anybody online? Great. Yeah.
This gives us a lot of food for thought, I think, on how we can affect and impact these different definitions of what adversity means and so forth. So what is the process for stakeholder engagement and input to defining what adversity means to a variety of different groups and as well as the scientific community? What process is there for engagement to input and affect what you're talking about?
Well, I think, I see Jeff stirring. Jeff, do you have thoughts? Okay. Thank you for the bailout.
For the NAAQS specifically, at the beginning, there's a call out for information from the public. So we ask for any scientific information. That's at the beginning of a process, but you have to, obviously we have to communicate that better. That's put out in the Federal Register, and then you have to know to find it to give us information. Also, when we put together our integrated science assessments, there's public comment, and public can give comment to what's in the science, and also all the way through the policy making and through the rulemaking process. So there's lots of input for the public. You just have to know when that is, and obviously we could do a better job of doing that.
And groups like Sierra Club and other people take advantage of that, but I think that's one of the tools that can be used to sort of inform this conversation. I think also if putting things in your publication that contextualize what the effects are and what that might mean. So biomass declines of forests, is 5% bad? Like that's useful to know in a contextualized way, and that can also be brought forth into these scientific assessments and then into the policy decisions. So
yeah, and also one of the reasons putting together this talk is trying to open up the conversation so you can talk to us and also be a part of our hopefully symposium or special issue to sort of open up, at least for the scientific community, that conversation.
All right. Thanks.
So our next speaker is Sarah Jovan, who I can see up there, though I can't see her. There she goes.
How does that look?
Looks great.
All right. Let me turn this down real quick. All right, well, thank you for being here. I'm going to talk about measuring heavy metals in moss to help guide an environmental justice investigation. And so this is a case study that we did using community science in Seattle, Washington. And I want to start off just by acknowledging my 12 co-authors who helped write the paper based on this study, which is really just a small subset of the folks who worked on this project. So we'll discuss that in a moment. So I'm going to give a very quick explanation of moss as a bioindicator, then spend some time talking about community engagement in the research, which is really the core innovation in this project, because, you know, this isn't our first moss rodeo, so to speak, but it is our first, and also the first that I know of in the realm of bioindicator science to use a community science approach. So finally, we'll touch on the main results and outcomes. And I want to save time for questions, so I'm going to go kind of quick. Okay, so moss are great bioindicators of air quality because they've evolved to very efficiently scavenge all their nutrients and water from the atmosphere, which also means that they can be very good at trapping, absorbing, and accumulating pollutants as well. And the same concept applies for lichens, which we tend to use similarly as bioindicators. So just at the high level here, you know, we collect the moss and we send it to a Forest Service lab in Grand Rapids, Minnesota, where they use ICP-OES to extract heavy metals and a variety of other co-occurring elements from the moss tissue. So this current study adapts lab and field protocols that we used back in 2016 in a prior moss study, which we're not really going to get into except for as a point of contrast. So that study was started by scientists curious about what fine-scaled pollution, heavy metals, what the patterns look like across the city. And that blew up into this crazy bundle of energy and politics, a very frantic bundle of energy, when we detected some unexpected air quality issues that ended up being some pollution sources on the edge of neighborhoods that just weren't expected to be there. And it had some very high level impacts, which is great, but it ended up just finding these issues the way we did, causing the affected communities and agencies and involved stakeholders to have to scramble in response. So it was a really tough experience for everybody involved. So for this study in Seattle, I'm going to introduce with the acknowledgements. You know, in contrast, this study has actually been executed much more gracefully, I think you'll see, and kind of in an opposite way. You know, we started with building partnerships first, and it also helps that we focused on an area, like a specific area with known air quality issues. So we focused on the Duwamish Valley of Seattle. So this study was in fact initiated by two Duwamish neighborhoods, Georgetown and South Park, who have had some long-standing concerns about air quality in their neighborhoods. So we'll touch on that in a moment. And then from their initiation and reaching out, the group working on this grew to include over 55 people from more than 10 organization. So this was a highly collaborative project. So the Duwamish Valley has a very complex social and economic history that I can't really do justice to in this amount of time, but in brief, it became Seattle's main industrial hub over 100 years ago. So there are many legacy sources of heavy metals and other pollutants in the area. For instance, a lot of the river, 8 miles of it in the lower Duwamish watershed, is a Superfund site, which includes all the river bisecting our study area in the yellow box. The banks in the valley here contain dozens of sites of soil contamination and in various stages of cleanup. And of course, this is still a very happening industrial area. So, there are also many extant pollution sources, different kinds of industrial point sources. There's a lot of transportation sources going on in here, as you might imagine, on the river. There's some rail, there's a Boeing airport, and there's a lot of highways and a lot of diesel truck traffic going in and out of the area. So in a nutshell, it's really complicated. They have a lot going on there. So, so Georgetown and South Park are widely considered environmental justice communities. Health disparities among residents are really well studied. A couple examples include lower life expectancy and higher heart disease rates than the rest of Seattle. Asthma is also quite a big issue in these neighborhoods in terms of its prevalence and severity being much greater than elsewhere in the city as well as the county. Additionally, this area has more people of color, and it also has more people living below the poverty level than the rest of the broader area. So, it's widely expected that air toxics are a driver of some of these disparities, and there are some highly modeled data sets and studies that would agree. But part of the inertia, it's all very complicated, but part of the inertia in taking action and addressing some of these health disparities from air quality boils down to the lack of actual air quality measurements. So in this map, you're seeing how Georgetown, which is here, and some residential areas sprinkled through there, and then South Park, which is mainly here, and then some residential areas sprinkled through there. You can see how they're nestled in this valley, adjacent and somewhat interspersed with a lot of industrial land, as well as a lot of the transportation corridors I mentioned. In this area, as valleys do, does experience periodic stagnation events. So you can see there are 2 air monitoring sites here and here, which at the time did not measure heavy metals. So as you can imagine, by sampling moss, which is pretty inexpensive, at all these sites, it's the blue dots, we could produce a first look at neighborhood scale patterns to help guide community decision making. So local youth led moss sampling, which everyone was very proud of. I wanted to say, unlike a lot of collaborative or citizen science studies, community members were involved in all stages of the research process, sometimes in a leadership role, and sometimes not, but nonetheless involved in things besides just data collection. And so to oversee the collaboration, we formed a steering committee that met regularly and that was led by community stakeholders. So here's just some more slides of the action. The first thing we did for QA purposes is experts revisited some of the sites that the community and students sampled for moss. And we were able to show that there was good statistical agreement between the two data sets, which is great. So everything we see going forward is based on the youth and community data. So we'll just touch kind of high level on what we found. So our top 3 results. Number 1, we found that heavy metal levels in the Duwamish moss were higher than similar studies. And so this helped the community decide to take the initiative and use the resources to investigate heavy metals further. And this is key because, as I mentioned, there are a lot of potential air toxics of concern in the area. So, time, energy, resources need to be well spent. So to demonstrate, here are box plots, and you can see the Duwamish moss in these orange boxes. In all cases, we're higher than similar moss data sets from our Portland data set, which actually was over 346 samples. It was across the city, so it's a pretty extensive data set. And then SCP is another data set collected in Seattle City Parks by that agency. And the 2 most extreme differences were for arsenic and chromium, where you can see that almost all values in Duwamish moss were higher than the 95th percentile from the Portland data set. And if anyone's heard about that study, we had some pretty high values in Portland. Okay, so number 2, it bears repeating that, maps provide this fine scale perspective, and that helped the community prioritize where to focus the further investigation. So here's just some dot maps of the metals, and I realize that this is a little busy to look at and you probably can't read the labels, but the key point to know is that when you compare all these metals using principal components analysis, you see that their spatial distributions had quite a lot in common, with peak values tending to occur in the central industrial area and up in the northwest corridor here. So, residential areas near those peaks became priorities going forward. So you'll see this creeked map again in a couple moments. So finally, while we won't go into it, some correlations between metals and soil elements in the moss suggested that resuspended soil and dust, aka coarse particles or PM10, may be important carriers of heavy metals in the Duwamish. As you may know already, a lot of monitors focus on PM2.5, the fines, and very rarely look at PM10. So, this combined with the area's history of soil contamination, they also have some unpaved roads leading into and out of the facilities where there's a lot of heavy truck traffic, lots of potential for resuspension, helped the community decide how to investigate heavy metals, meaning by looking at the larger PM10 fraction. So getting ready to wrap up here, as far as outcomes, so social benefits, there are a lot. After the study, a lot of funding became available where, for instance, City of Seattle approved some funding for some urban forestry and greening investments, which allows, some immediate action taking mitigation measures. So finally, you know, with these data in hand, the community was able to successfully advocate local regulators for follow-up study using air monitors. So they together decided where to place these monitors. There's 6 of them measuring PM10. And this is fantastic. I feel like you all already know this, but you know, these concentration data are what's needed to close the loop, you know, on whether heavy metals levels in the valley may be hazardous to human health and contributing to those health disparities. You know, we use MOS mainly as just the screening tool for that. So I think I'm almost out of time. I think I'm going to stop there so we can take some questions.
So we have 5 minutes for questions. I'm looking. We have a question in the back.
So do you know when the PM10 data from the city, well, the city or county, when that will be available and where?
Yeah, actually, hold on 1 second if I can figure out how to go back here. Yeah, I mean, actually, I'm gonna turn this down. I'm getting some echo. Hopefully that's better. Some of the data have already started to come in, and so I'm just displaying some really preliminary data here. Sorry about that echo. I'll turn it down for a second.
Oh, we don't
Anyway,
have an echo
so
at this side.
there's actually more data on their way, and my understanding is that it will all be available along with the synthesis of what it means, you know, some looking into what maybe the cumulative health implications are in early 2023, which is actually a pretty fast turnaround, I thought. And there's a website dedicated to displaying the data. It's been, you know, with these community data sets and interactions, everyone wants the data right away and they want to see it. And that's fantastic. And I understand that desire. It's hard though when you have some data and people are like, oh, you know, like arsenic's a little bit above the cancer screening value. And, you know, you're kind of left to your own interpretation. So people are kind of nervous not knowing what these things mean. Nonetheless, there's actually a website that Puget Sound Clear Agency put together that very nicely graphs all the data, and they've been updating it as the information becomes available.
Thank you.
We have another question.
Thank you. Thank you. It's a really nice talk. And my question is that you said the sources, trace metal sources may come from the suspended soils or solid. I'm wondering, are you planning to do the further tests, such as using the isotope analysis to further trace where these sources comes from? And my next question that, have you ever compared the forest and the mosses concentration difference? Just curious. Thank you.
Yeah, I mean, a lot of the work we do, you know, involves more forested areas or gradients or comparisons between urban and less urban areas. So we have looked at that before, and you know, when you're used to working in more natural areas, some of the urban values we get can be really shocking, and you know, orders of magnitude, multiple orders of magnitude greater. As far as isotopes, you know, I'd be curious to know more about that. In this particular area, I don't know of anyone planning to do any isotope analysis. We are in the Portland area using lead isotope analysis to look into different sources of the lead patterns that we're seeing there. I guess I wasn't aware of other potential ways to use isotopes, but I'd definitely be interested to hear more about it. Part of the issue, as you've probably picked up on, is there's such a density of sources, including the legacy ones, et cetera, that it's just really hard to figure out where things are coming from. So any tools to assist with that would be really welcome.
Well, thanks again, Sarah. And I think we have to hold. There's one more question. If
Do we have
can
time
be
for the question?
Very quick,
Okay,
because we are out of time.
Okay, great talk. Just a question about the moss, 2 parts. How easy was it for the community members to identify the moss for the species? And secondly, were these all growing on trees or some nearer the ground?
Yeah, so these are all growing on trees. And we did get some of the wrong mosses. You know, it takes a while to develop an eye. Luckily, this particular moss we used is extremely hardy and extremely abundant on hardwoods. And it doesn't seem to be excluded by pollution. So, you know, like 90% of what you're gonna run into, you know, outside of a wooded area in a city is gonna be this moss. So that, I think that helped us out, but you know, that was part of the curriculum for the youth, was going through, you know, the different mosses and looking at them and such. And at the end of the day, I mean, these guys were 8 to 12th grade. I was impressed with their ability to identify the moss. And yeah, it was all on trees, which helps, you know, standardize a little bit some of the microsite variability you can run into.
Great. Thanks again, Sarah. And I'm going to let you revert back to your co-chair role. And our next speaker is Susan Sachs from the National Park Service.
All right, let me just, I don't know how to move that a little bit, so it's kind of making me cross-eyed because it's right in my eye. How do I lower it? Is there a way? Maybe it's here. Just a little bit, a couple inches. Sorry about this. Oh, there we go. Pretty easy. All right. Well, good morning, everyone. My name is Susan Sachs, and I'm the Education Branch Coordinator in Great Smoky Mountains National Park. So let me just make sure, hit the right button there. So I want to welcome you to our region. It's the ancestral homeland of the Anagadua, the people of Gadua, who happen to be known by most of you as the Cherokee. So welcome to the homelands of the Cherokee. I work in Great Smoky Mountains National Park, which is not very far from here, so you're very close by. And it is known by the Cherokee as Shikanahe, which is the land of blue smoke. And it is often confused with air pollution here in this region. And many of you who are immersed in air pollution issues probably know that the Smokies for many years was known as the most polluted park in the country. And this is some data showing you improvement, which I always think we need to celebrate our successes. And you can really see over time, our NOx and SOx levels have dropped dramatically. A lot of that has to do with regulation here in this area. North Carolina passed something called the Clean Smokestacks Act in 2003, which really was implemented by 2009. And then there was some lawsuits that happened. It's a pretty complicated history, but TVA, as well as the state of North Carolina, ended up cleaning up all their coal burning power plants. And you can really see the impacts of this. you'll see a black line kind of going a little right of center, and that is when I started doing some of the education projects that I'm going to be talking about in my talk. And the two previous talks work really well, so whoever organized these talks, you did a great job of setting me up, because I'm really talking about how we use community science, mostly middle and high school students, to collect data looking at those secondary standards. So we're looking at the resources of Great Smoky Mountains National Park, and we're using students. So I have a similar slide. The next slide is just looking at ground level ozone. Similar improvements to what you saw. I don't want to make the case that everything in the Smokies is great now, because we still have some issues with mercury deposition and ammonia. I don't see Jim Ruffro here. I'm kind of surprised that he's not here, but he's online. Hi, Jim. Jim is an amazing scientist, and I also think he's an amazing educator, because he makes sure that the information that he collects gets out to the right people so that we can educate our community about these issues. And he's been very instrumental in getting Smokies data out to lawmakers, decision makers, and so forth. So, but you can see 2003 is really when most of the studies that I'm going to be talking about, that's when they started. So we in the Smokies, our educators, it's not just me, but a whole team of educators collaborated with research scientists, folks who were doing permitted research in the park, and teachers in our community. So we would meet with teachers, we'd bring the scientists in, we'd have park staff there, and we would look at the curriculum standards and say, how can we get meaningful long-term monitoring data? There's not always a scientific question behind our data. How can we do long-term monitoring using students in a way that will help, in a sense, I think of it as like a canary in the coal mine. So how can we keep our eyes on resources and alert the right people when we notice something changing or happening? So one of the first studies we started was based on research from Dr. Howie Neufeld and Dr. Art Chapalka, looking at the impacts of ground level ozone on sensitive plants. They were, had chamber studies to determine which plants back in the late 1980s, or 1998, I think it was. So we took one of those plants that happens to be culturally significant to the Cherokee. It's called Sochan. Many of you might know it as Rudbeckia licineata, or cutleaf coneflower. And the Cherokee, what they do, and I think I have a pointer up here. So this part of the cutleaf coneflower, this is the entire leaf. They take this front section that has 3 toes, they call that turkey foot, and that is what is collected, the turkey foot of the Sochan. It's collected very early in the spring. It's considered a spring tonic. So we use students in Cherokee as well as in our local communities to monitor the impacts of ground level ozone on the Sochan. And you can see we're looking at necropsy, total death of tissue, we're looking at chlorosis, and we're looking at the ozone symptom, which we call purpling. And you can see a really great example of what purpling looks like if you've not seen that before. The leaves are, the veins are still green. So students are estimating the percentage of total leaf coverage of those symptoms. We have students that come out throughout the growing season, and they're coming from local communities. One of the things about these studies, for us, it's important that students are empowered to continue to collect data. So all of our studies that we have are set up so they can be done in a schoolyard as well. We will share root cuttings of plants, and the lichen study I'm going to talk about in a moment, and some of our other studies, if schools want, they can actually collect data in their schoolyard as well as and compare that to our Park Service data. There's also pre and post site activities that teach them how to estimate when they come to the park. We want them to have already practiced those skills so that they can do proper estimation, learn about what the symptoms look like. So there's a lot of pre-work that is done by the teacher in the classroom. The data gets put up on, and this is for all of our studies, it gets put up on FieldScope, which is a platform we just started using. We have been using Hands on the Land, but that particular platform, I got a call during the pandemic in 2019 saying, or early 2020 saying, we're going to get rid of Hands on the Land. And I was freaking out because I had almost 20 years worth of data on that website. But I was able to find FieldScope, who has been a great partner for us. So all of our internet databases, that way teachers can access data if they do want to do comparison between their schoolyard and what we collect in the park, or they can just do analysis looking at data. So this is a very old data analysis done by a high school student. Part of the reason I'm showing this is it's an original question that that student asked, but the students don't always share with me their data. So what they do back in their schoolyard, I'm not always involved in that part of it. So this just happens to be one student who decided to look at the 4th highest leaf across. We have 20 plants that we collect data on. So she randomly picked 6 plants, looking at the 4th highest leaf, and what was the rate of increasing symptom on the leaf, and when did it fall off? So the leaf falls off, it looks like a straight line. That's when the leaf is gone. So we don't graph it as the leaf getting better. It doesn't drop off to 0, it just continues at the level it had been at. And you can see there's actually, and it's not the prettiest graph. She didn't, I would have wanted her to invert the damage levels on the side, because 6 is a injury of 76 to 100% total coverage of the purpling. But there were 2 weeks, one in early July and one in late July, where most of the leaves at the 4th highest fell off of that plant. So we could go back and look at ozone levels during actually the few days before those weeks and see that we actually did have exceedances. So there was a little correlation. But that was a high school student. This was just one of the graphs from her particular paper. So I'm going to just talk about very quickly some of the other studies that we have. We're looking at the impacts of acid deposition on a lot of different resources in the Smokies. Salamanders are one of our iconic species. And here we work very closely with students. The eastern band of the Cherokee have the Qualla boundary just outside the boundary of the park in Cherokee, North Carolina. And we work very frequently with high school students to study the impacts of acid deposition on salamanders. And really, we're looking right now, we're collecting a lot of data. Our metadata is probably the most important data for this study, and that's the soil pH, the soil moisture. We're looking at phenology as well. And just seeing over time, are we seeing any abnormalities in the salamanders? We're looking at a little bit of movement. We have tree cookies set out, so we're looking at distance from the stream. So there's a lot to this particular study, but we do use, we probably have about 600 or 700 students a year that help us collect data for that study. We do have a lichen monitoring study as well. We have locations at various elevations throughout the park where we have trees that we always go to those same six trees and set up these. We use transparency paper, which is really hard to find now. Nobody uses transparency paper, so you can buy a package of 25 for $60 now, which is blows my mind. So we're trying other techniques, those page savers that you find in notebooks are currently what we're using, because transparency paper has gotten so expensive. But we're really looking at total lichen coverage. We're classifying crustose, foliose, fruticose lichen. Certain types of lichens are sensitive to sulfur in the air. So we teach the students about where's the air pollution coming from, why does it carry to the Smokies, why does it get trapped in the Smokies? So we're talking a lot about the geography of the area, and then what can we do about it? So solutions are all part of the discussion. We also have a middle school program that looks at soils. So students are collecting data on pH, again, soil moisture, and then they get to sift through leaf litter to see what lives in soil. Again, we're getting really great phenology information. what types of critters are more active different times of the year, which when we started this study, we weren't thinking about climate change, but we're actually getting good climate change data in there as well. And then just real quickly, we are part of the Dragonfly Mercury study that's part of the NPS. And again, we use local students to help us collect those samples. A lot of our water quality issues, almost all of our water quality issues in the Smokies are because of air pollution. We have very low pH in our high elevation streams, so we do a lot of stream monitoring. Again, we collect the chemical data as well as looking at the critters that live in the creek. For me, one of the more fun studies that we do is looking at what lives in lichens, because students are collecting data on lichens, but once they realize that they're a habitat, and you can find things like tardigrades and rotifers and nematodes using microscopes, they care a little bit more about the lichens, because it's this whole little Horton Hears a Who world that they couldn't see. And then they realize, you know, I've seen kids be like, so could we be the tardigrades on somebody else's like little, I'm like, we could. And then like, no, you're blowing my mind. But anyway, my favorite study actually is our snail study. We're looking at impacts again of acid deposition and calcium being one of the nutrients. When you have low soil pH, the calcium will actually start to leach out of your soil, end up in your creeks. Snails, terrestrial snails, of course, do need calcium to make their shells. So what I hope to do is, as an educator, encourage you all in the room who are scientists to make sure your information that you're collecting gets out to the right people so that they can help inspire the change that we need in this world. You know, our students are our future, and there's so much you can do with the data that you're collecting. And I think, you know, the work that I've been able to do with Jim Renfro and other scientists who work in our park shows that, you know, you just never know where your data and your method, how it's going to inspire to create change. So thank you. Here's my contact info. Maybe one question? All right, great, thank you.
So we have one more talk in this session. Deborah Souter. Deborah comes to us from University of Maryland, Eastern Shore. There you are.
Oh, that's great. Thank you very much. Good morning. I think it's still morning anyway. I do come from the University of Maryland Eastern Shore, and just before we get too far into this, I want to give a shout out to any other representatives from 1890 institutions in the room. Aside from my colleague, I think we might be it. But we are an 1890 institution, an HBCU, and we have engaged with some colleagues that I'm going to talk about here in a minute in the first measurement of ambient air quality on the rural lower Eastern Shore of Maryland. So for those of you who are not, lower Eastern Shore folks, we'll get to that in a second. Our goal is to evaluate the impact of commercial chicken houses on ambient air quality. And for those of you who don't know, Frank Perdue was born in Salisbury, Maryland on the lower Eastern Shore and established his practices for raising chickens there, starting, I think, as early as the 1960s. All right. Where is the lower Eastern Shore is the first question we'll answer. I'll highlight our partners. We'll give you some information on why this is of interest. We'll talk about the economic and socioeconomic situation at our sampling sites in particular. And today we're going to focus on 3 measurements that we've been making that are of particular interest to the chicken industry, ammonia, PM2.5, and PM10. Well, I have the results and hopefully some time for questions. And I apologize, there's a lot of slides here I'm going to zip through. This is a map of the lower Eastern Shore. Annapolis, of course, is the capital of Maryland, so it gets highlighted on any of these. And all of you probably know where Washington, D.C. is. In between Annapolis and the lower eastern shore is the Chesapeake Bay, certainly an environmentally important center on the eastern shore, on the eastern coast of the United States. And our sampling sites are located in Princess Anne, Maryland, which is where the university is, and south of Princess Anne in Pocomoke City, a small town, a little bit south, 19 miles south of Princess Anne. We obviously occupy a very environmentally sensitive area. And unlike the previous talk where Susan gave us, we have a maximum elevation of about 30 feet above sea level. Okay, this is flat land, all right? All right. This is an overhead shot of Somerset County, and our farm, our extensions research farm is on Stort Neck Road, about 3 miles from the campus, which is just off of this map to the northwest. There are no chicken houses within 1 mile of this sampling station, and there's only one chicken house within 2 miles. And so MDE coordinated with us to identify this as a good site as a comparator to the second site at Pocomoke, which is a mixed farm, business, and residential community with lots of chicken houses within 1 mile. And those chicken houses are shown in this map in the yellow boxes. The estimate from the Delmarva Chicken Association is that there are 1.6 million chickens within 2 miles of this sampling site. Okay. So the partners who are engaged in this work are the University of Maryland Eastern Shore. I'm a chemist. My colleague Bernice Bediaco has her PhD in toxicology and is currently a postdoctoral research associate with us and teaching associate. She's got a split personality. The Delmarva Chicken Association is the professional business association of the chicken growers on the Eastern Shore. It's been, I think it was established in the early 50s and is a big player and very, I think, socially connected with the communities on the Eastern Shore. We are currently funded by the Keith Campbell Foundation for the Environment, which is based in Annapolis, and I think also does a lot of work on the West Coast. So those of you in California, Oregon, and even up into Seattle probably could take advantage of their funding availability if you're so inclined. And of course, we're collaborating with the Maryland Department of the Environment, which has provided us with the resources and the technical support that we needed to get this project underway. Okay, so why care about air quality on the lower Eastern Shore? Well, even though if you look at a list of the top 5 chicken producers in the US, Maryland does not appear on that list. But of course, we're a small state. The lower Eastern Shore is a smaller piece of that small state. And this quote from Bob Mosley from the DCA highlights that 12% of the poultry that consumers in the United States rely on comes from Delmarva, okay? And Delmarva is the area east of the Chesapeake Bay, Delaware, Maryland, Virginia, okay, between the Chesapeake Bay and the Atlantic Ocean. The immediate reason for this particular study was a very vociferous citizen who called up MDE and said, there's too much ammonia at my house and it's affecting my health. And that individual citizen kept that complaint going to the extent that MDE called in its partners and said, okay, we need to figure out how to address this concern. Okay, so you too can get a response. All right. The socioeconomic data. Pocomoke City, the southern chicken-focused community, is in Worcester County, Maryland. In the 2020 census, its population was 52,460. That was a slight increase over the 2010. There's a high percentage, I would say, of persons over 65 in the county. 90.8% of households had a computer, which of course was important during the pandemic. And the median household income is relatively high, at least for the Eastern Shore, at $65,396. The population density is considerably higher in Worcester than it is in Somerset. Somerset County is widely known. It's widely known as home to the University of Maryland Eastern Shore. It's also widely known in the state as the poorest county in the state of Maryland by most any socioeconomic data set you want to look at. The population is lower at 24,620, let me get that out of the way, and has declined slightly since the 2010 census. We have a more balanced population distribution, I would say, fewer households with a computer. Broadband access is a real issue for most of these rural communities on the Eastern Shore. It continues to be an issue even after the pandemic. Median household income is the lowest in the state. All right, the percentage of persons in poverty at 22.2% is the highest in the state. And so we have sort of a built-in DEI kind of concern here between these two counties and the results of this study. Okay, ethnically, there's a pretty good distinction between the two counties, and I got tired of numbers, so I made this pie chart. I'm sure you can't see the numbers that are on the pie chart, so let me highlight that that Worcester County is 83.4% white, and this is someone who identified as a single, a signal ethnicity or as white. 12.5% Black or African American. But Somerset is only 54.5% white and 40.9% Black or African American. And so we start to see the diversity. The American Indian population is very small in these communities, but it is there. The Asian community is small, but it is there. And a certain percentage of our residents do identify as two or more races. And if you look at the source of this data, the 2020 census data, it also included a category of white, not Hispanic or Latino, which I removed from this data set because it overlapped too much with the rest of the data. Okay, so what air quality measurements are we making? We are part of the AMON network. We have AMON samplers at both of these sites. And we've used that to compare to the hourly data measurements we get from a standard air monitoring station that you're all probably familiar with. Ours is provided by J.J. Wilbur. I assume they're sort of the big players across the country, but I'm a little new at this, so I just wanted to identify that as our technical basis. We're measuring ammonia, we're measuring PM2.5 and PM10, and we're measuring weather conditions continuously, 24 hours a day, 365 days a year for 2.5 years now. And we've got funding, hopefully, to continue for at least a 5-year study. This data is all posted on the Maryland Department of the Environment's public site and is available to you as it comes in. Okay. All right, so we're going to start talking about ammonia first because ammonia is the issue that the citizen raised when they started complaining to MDE and that initiated this project. The ammonia parts per billion for the 3 years, we started in April of 2020 is when this project started. So that green line, yeah, that still looks, you can see the green, is the 2020 data. I've overlapped that with the 2021 data, which we have the whole year, and 2022, this goes from January till October 31st. Okay. The top graph shows you the Princess Anne site, where, remember, there are no chicken houses. We don't expect too much ammonia in an area with no chicken houses. The two stars, because we're on site at the university, we were able to talk to the farm manager about what the hell they were doing on the farm. Okay, and it turned out that within 48 hours before those two spikes, they had applied UAN by dribble application to the cornfields immediately adjacent to the sampling site. In 2021, they grew soybeans on those fields and not corn. So this is a pretty clear indication of the impact of fertilizer use if you live in a rural community and are concerned about your ammonia concentrations. The lower graph shows our data from Pocomoke, where the 1.6 million chickens are happily chugging along. And you can see, I think, an obvious increase in ammonia emissions down there. But of course, ammonia is not regulated by the EPA. We don't have, any primary standards here to compare to. And so we're sort of mushing along here with the guidance from the MDE. All right, so this is our statistical data, 2020, 2021, 2022, and then the full 32 months of data we've got. Pocomoke has a statistically significant higher ammonia concentration than Princess Anne in the first 32 months of this study. Okay. We did the same using monthly averages in a different statistical package so we could make sure we weren't screwing something up because we're sort of newbies at this stuff. And we got exactly the same result. Pocomoke has a statistically higher ammonia concentration than Princess Anne. This was over the first 29 months of the study. Okay, then we turned our attention to PM 2.5. And PM 2.5, if you're looking at these graphs, there's not a huge distinction there. It's a little bit harder to see what's going on. And since this data comes in by hour, I should mention that my horizontal axis here is hours in the year starting at midnight on January 1st and going through to the end of the year. All right, but when you do the statistics, okay, the PM 2.5 statistics, I'm going to slide past this one to our next set, shows that Princess Anne actually has a higher PM 2.5 than Pocomoke. And that, for me, this was unexpected. I had anticipated that the 2.5 would also be affected by the presence of chicken houses. Something else seems to be controlling that. And at this time, I'd be very happy to talk to anybody who has a theory about why that might be. Using monthly averages, we also see that Princess Anne is statistically higher for the first 29 months of the study. And since PM 2.5 is regulated, we have the air quality index we can mark. And so we have studied or evaluated how many hours the readings were over air quality index limits. And we do have both moderate and unhealthy measurements in Princess Anne and Pocomoke. Princess Anne clearly has more hours over the primary limits for the first 32 months of this study. Okay. On the PM10 side, these are the PM10 data, again, on an hourly basis. I don't know if what your eye sees there. Mine was confused when I looked at this. The statistics on PM10 are a little bit compromised because we had I think we had a lightning strike, we think, at Pocomoke in 2022 that sort of took everything down for an extended period of time. And so instead of the 7,278 hours of data that we had at Princess Anne in 2022, we only got 6,360 hours of data out of Pocomoke. And so I'm a little hesitant to draw too many conclusions from this data, but I can say absolutely that each of the sites reported 1 hour above 150 micrograms per meter cubed for the first 32 months of the study. And so that puts us at risk, I guess, of violating federal standards here. We'll see what happens the rest of this year. I got more statistics here, but let's just go to the air quality index measurements. This is the air quality index for PM10, both at Princess Anne and Pocomoke in the 2 columns, and year by year, and then an aggregate. And again, this is a hard statistical analysis to make. These 2 sites appear to be pretty comparable based on the data that we've acquired so far. So in summary, we have ammonia with its, we see an impact of the ammonia concentrations from the concentration of chickens in Pocomoke City. Pocomoke is definitely statistically higher than Princess Anne. But the amounts are averaged over 32 months, 4.77 parts per billion in Princess Anne and 10.16 parts per billion in Pocomoke. MDE has established its 1 hour screening level at 350 parts per billion. And so we're not anywhere near that, even in the most concentrated chicken growing community that we found. And so the chicken folks were very happy to see these results. Particulate matter is just ambiguous as far as PM10 goes. I had expected to see elevated PM10 during harvest, when the combines are going and the dust is flying, but I don't have enough data to draw that conclusion. So if anybody has ag experience and can help me understand why that's not happening, I'd appreciate the input. We do have PM 2.5 in Princess Anne of 7.6 micrograms per meter cubed, and Pocomoke is 7.02, and that is statistically different, according to our analysis. Princess Anne definitely has more hours where PM 2.5 exceeds primary or secondary limits than Pocomoke, but chicken houses just don't seem to contribute here. Now, based on DEI, right, we would say, okay, good. We've got this community, Princess Anne, which is at the bottom end and higher African-American population than in Worcester County. But there's a caveat here. And here's my caveat about Worcester County. The big red heavy line there is the boundary of Worcester County, according to the Maryland state map. Okay, what you will notice if you look at this is that Worcester County includes all of Ocean City, Maryland, all of the communities, retirement communities around Ocean City, Maryland, Berlin, Maryland. That upper corner of this county is substantially richer, whiter, and older than the whole rest of this county. And that motivated my question earlier about sort of more micro scale statistics, because our sampling site is down there where that black push pin is. It is right smack on the edge of the county, and Pocomoke City has very different demographics and economic situation than Ocean City, Maryland. Okay, and I probably have 30 seconds for one question, so I apologize. But thank you very much for your attention. I appreciate it. Do I have time for one question? Or are you going to, okay, anybody? Or comment? I'll take a comment even. Okay, thank you.
I appreciate how passionate you are about it.
Thank you. We got sort of drafted into this, but I started, my very first undergraduate research project was on the Chesapeake Bay study in the 70s. And we did, we had a hand-built HPLC, and we did pore water studies on the big core things they stuck down in the bottom of the bay and sucked up. So somewhere back there, if you look in the 1970s, you'll find my maiden name listed as a reference.
I can take care of the rest.